Hello, students. This is my first, lecture. And as promised, you don't have to look at my face in the corner. You students have had me before know I don't really like to do PowerPoints, but I want to do it at least for now, for this one, just to give me kind of a structure to what I need to be talking about. I do recommend looking through the PowerPoint slides and, of course, reading the material. But I just wanted this to kind of like going through these slides. It gives me an opportunity to highlight some things that are mentioned. So this is kind of like a history and what's the point of Linux kind of lecture. So I have a little bit of opinion on some of the things here. And I guess we get started because this is 48 slides. I might rush through some at the end. We'll see, but I don't want to take up. Normally, I like my videos to be at 5 minutes would be great, but under 10 for sure, and this one probably won't be under 10, so we'll see. All right, so these are the objectives. You can look over them. So it goes over what an OS is, because Linux is an OS, so an operating system, so you gotta know what that is, right? And then what makes Linux kind of different from other ones maybe, and the background and how it's used. And you guys, I assume at this point, I think everybody's had some prerequisite classes, so you should know what hardware versus software is. Stored program concept of computers. It goes back to that in history. Alright, so, and of course all these things. This will come up a little bit later when we're talking about OS. We're about to talk about operating system in more detail, but when I talk about the resources and hardware resources, this is what, these are some of the things that could be things that you would, consider in that. Alright, and I do want to talk about this. This is kind of important. Sometimes the operating, because we're about to define operating system, and sometimes people will define it as the interface between the user and the computer or the hardware or whatever. That's not accurate totally, in my opinion, so I try to stay away from that definition. It seems like this material does too, but there is no way for the computer, the human to touch directly the operating system. In a way, what I'm trying to say is everything is an application that the user interacts with most of the time. So there's also operating system level software that's usually got protections on it. So that, only the kernel, the operating system itself, determines how that's used, but you can kind of give it orders through your application. So an example of what I mean here is when you talk about the interface between the human and the computer, that's going to be the application level. So whether it's a command line, that's an application that's running on your computer, and the humans interacting with that, typing commands and hitting enter, and then those are carried out by the operating system, and at some level or another. Same with GUIs. You click on something, that's interpreted by the operating system software or components that are sitting right on top of the operating system software. And then it, carries out what you do. So that's kind of a better way of thinking about it. So applications, all the things that the user actually does to interact with the computer will be at the application level. All right, we'll talk more about this in further slides, I think. So device driver, that's software. So here's what you got to imagine. The operating systems are different from each other. So if you have the same hardware device that can run on many different types of hardware, like a Mac, a PC, or Windows, Windows PC, or a Linux, or what have you, then the device will have to be given orders from that thing and give feedback to that hardware in maybe different languages. So the device driver, think of it as the interpreter between the two. So it's software written for that operating system that understands what the hardware expects is signal sent to it. So here's a signal that starts, reading from a sector on a disk, for instance. So there was, especially back, well, I imagine still today, but back in the early days, one of the hardest things about getting Linux installed on your computer running is that it would run all your your webcam or your USB stick, or I don't know if that's a good sound card. That's a good one. or your network card, or especially like a wireless network card. I had some issues with this in the early days. And the thing is, the different device drivers would enable different capabilities of your hardware. Some of them would ignore things, like back in the early days, there were wireless cards that you could stick it in the side of your laptop that would do monitor mode. And only some device drivers would actually mess with that at all. So the device driver you pick to run your hardware on your Linux machine would sometimes be important. So that's what a device driver, think of it as almost kind of like a GUI, not a GUI, but it's a user interface for your hardware almost, to your like the device that the not the system itself, but like the object you buy to plug into your computer. All right, and then you got the user interface. There's different, kinds of GUIs and command line and that kind of stuff, which is the first bullet point there. See? Okay, and this is just like a simple diagram of like the levels between the user and the operating. It's kind of like reiterating what I said before, that obviously there's application software between the computer user and the operating system, and then the operating system sits directly on top of the hardware. What I want to say about that a little bit too is that operating system allows you to interact with the hardware indirectly through software, but it also controls how you do it. So one of the jobs of the operating system is to make sure that things that are coming from software are not messing up how your hardware runs. So there's all kinds of duties that your operating system has, and there should be a slide here we get to that defines what an operating. So if you notice a skip, it's because dogs bark. We have to pause and resume, and I didn't like where I was at anyway. So I went into like the word history. It comes from opus, Latin. The plural is opera. Combining form is opera, so that's why you get operating system. By the way, yeah, they're works of art in music where you're singing. I guess that's why it's called opera. It might have been opus originally. I don't know. But anyway. So that's the etymology. It has to do with something that performs work. So it's the thing it's the software on your computer right on top of the hardware that allows your computer to do work. That's one way to think of it. Another definition I like for operating systems is it's a broker between processes or software that's running on your computer and the hardware. So it brokers resources. So resources would be anything that your computer can use to do things, like a printer or a network card or a keyboard, mouse, the screen, the memory itself, the CPU itself, any of the circuitry inside your computer, any of that hardware stuff, the software that controls how that operates, so to speak, how it works, is that's all controlled by the operating system. For instance, back in the day, you only had CPUs with one core. They only had one computing element in them. But Linux, and this is something we'll talk about in a second, Linux, Unix, these things, were multi-user, multi-task. Multi-user, multitask means you can run lots of applications at once, so one user can have several things going on, several programs he's running, and several users can have several programs running on the same machine with one CPU at the same time. So how's that managed? Well, the operating system has a scheduler that determines how much time each process that's running, and there could be hundreds of processes running, maybe more. It determines how much time they get to compute on the CPU before it switches to another process. So it's kind of like juggling. That's like a very, very low level, very important thing that an operating system determines, is how much time each thing gets on the CPU, even with multiple cores. It determines which process goes to which core, that kind of thing. So that's the very basic level of what an operating system is for, and it determines, when I say it determines which one, it's also kind of like privileges. Like it's the one who decides. The operating system uses rules that are written into it to decide how you determine which thing gets which access to which resource at what time. So that's the most important function of an operating system. Not just, it's not just an interface between the human and computer again. It's the thing that determines how everything works in the computer. All right. So back to our slides to kind of reorient it. I was on a kind of tangent there. So these are some of the things. System services, these are the things that, tell a printer how to print once you give it, like, I need you to print this paper. Everything from there down, the system service for printing interprets that command and knows how to carry it out. And these scheduling I want to assume that scheduling programs, they mean the computer, like what I was just talking about, scheduling time on the the processing elements in your computer to run. That's scheduling. It's not scheduling programs like applications for scheduling your calendar. It's determining how much time each thing gets to run while it's executing. Here's an example. GUI. They were talking about, GUIs is one of the applications that it runs, and that allows the user to interact with the computer in a sort of intuitive way. Here's one. I don't know which one this is. It looks like KDE to me. It might be GNOME. I can't remember the difference between. They look similar to me. If you put them side by side, to me, GNOME seems flashier. But anyway. This is an example from Red Hat. All right, so Linux, what's different about Linux? Well, Linux, it's not necessarily different, but it is important. Way back in the late 80s, early 90s, maybe, even Windows was not, wasn't multi-user. It was multitasking. But anyway, Unix, one of the prime features of Unix back in the time, which again, Linux, not again, I don't know if I mentioned this already, Linux is an emulation of sorts of Unix. It was multi-user and multitasking. So it's an operating system that said those things that I was talking about before. It allowed like maybe 5 users. That's not a strict number, but like say, 1, 2, 3, 4, 5, 6, 7 users to operate many different, to run many different programs at a time. So one user could be running like some calculations at the same time they could be chatting with somebody. That's 2 processes from one user, and another user could be doing the same thing. So multi-user multitasking. That's a very important aspect of Linux and Unix, where it came from. All right, the kernels, the core component. So yeah, it was originally written, well, so was Unix. C was more or less invented in order to write the Unix operating system. And so it makes sense that Linux was also written in C. Because a lot of programmers, especially back in those, Linus Torvalds, the guy who created Linux, knew C pretty well. If I'm not mistaken, some elements might be in C++, but it's mainly C. The kernel, they leave this out of all this. There's a good definition of the kernel. I think it really helps you understand what the kernel is. It's that part of the operating system that is always resident in memory. So when you start up your computer, the operating system's not in memory yet. There's bootloaders and stuff on the disks or whatever the boot device that starts the computer is that will give instructions to where the operating system is located, and it will take that and put it into memory and start running the computer, start doing the operating system jobs. That piece of process, that piece of programming that's in memory and operating as the operating system, that is the kernel. The operating system can be bigger than the kernel, and one way that's true comes to mind really quickly is things called modules in Linux. So for instance, you have, like I was talking about before, used to be how it worked a lot. If you had a wireless card you plug into your laptop, it wasn't always there, but once you did, the kernel would detect that it was installed, and it would say, hey, do we have a device driver for this somewhere? And if we do, where is it? And then it loads that device driver into memory and adds it to the current operating system running in order to talk to that wireless card. So that's just one example of how the kernel and the memory are the same thing. The kernel and the operating system are not the same thing. The kernel is a subset of the operating system as a whole. The kernel is that part of the operating system that's always in memory running. It's the necessary and sufficient domain of the operating system for actually just basically running your computer. And of course, there's different versions of kernels. As people they want the operating system to do more things or do things in a cooler way. Maybe somebody writes a new scheduler that runs processes more efficiently than one before, or something like that. as these things get added to the kernel, you have kernel versions, and that's kind of how you're tracked about where your progress in the evolution of Linux is your kernel version. And it's important, like for some things that you're doing, to know which kernel version you're working with. All right, so that's the kernel. And so memorize this. This is a test question. You start with the major number, then you got the minor number, then you got the revision number. These are just like ways of keeping track about where you're at in the kernel. Like a huge big redesign of a kernel is going to be a major number. Then maybe like you find out after running it for a while that something doesn't work quite right. It might crash every now and then. This weird thing happens, so you do like a small patch revision. That would bump up the minor number, and then even even smaller changes would be the revision number. Just remember that order because they come in that order on the little quiz you take. All right, open source software. This is just a philosophy about like developing software that's open to everybody to collaborate on. So nobody really owns it. I don't want to say it that way, but it's open. There's an open invitation to other people to take the software and then like make changes to it. And there's different licenses and legal devices for this, but the main one we'll talk about is the GPL, I think it's the GNU Public License. And of course, source code is just the stuff that human beings wrote in order to that gets turned into machine language for an application on a computer. All right, so these are some of the pros. You can, if you've got a bunch of people collaborating freely on something, there's an opportunity for things can be developed faster and bugs found more quickly. And the features, it could mean like on my computer this thing doesn't work, so I'm going to write software to make it work. In the early days, a lot that happened. Again, with like, hey, I've got this sound card that doesn't work, I'm going to write the device driver for it, and then you share it so other people with your device driver, your sound card, could use it. So I mean, there's pros and cons here, but like maybe the person who wrote the device driver that people use wasn't like the best person for it. Maybe there could be a better version. There's pros and cons, but in general, it's going to make things happen a lot more quickly if people buy into this philosophy. Okay, another interruption there. If you notice an edit, I did want to talk about the license in particular that's most covers most of Linux, and that's the GNU Public License. So. Otherwise known as a GPL. And just to go in, there's a website for it if you want to look at it. This is the name, by the way. GNU's a recursive acronym. We'll talk about that later if you want, but I won't get into too much detail. But it's an acronym that has the acronym in the acronym. So it's pronounced GNU. So that's why I said, you might have noticed I said GNOME earlier. That's because that's a GNU desktop environment for Linux. Desktop environment is something that has like a window manager and like lots of other like basic things that you need to run a desktop on a computer, like I don't know, maybe the calculator or something, or other things. File manager, where you go look through your different files, the folder manager, that sort of thing. Anyway, that's why I said GNOME, because that's part of GNU, and it's all the GNU stuff's pronounced GNU. So anyway. That's these guys. There's a lot of stuff that's licensed as GPL, and the basic way that works is, correct me if I'm wrong, somebody, but it's anybody can take something that's produced under the GPL license, the GNU Public License software, for instance. It's going to be open for you to see, and you can go in and change how it works, maybe, and then you're free to release it. Like you can even charge for it, money for it, but you have to keep it open. And you have to keep that license in it. You have to copy that license forward with it, so it becomes under the GPL if you develop something from the GPL, and that sort of like allows things to grow and metastasize or whatever, and spread and evolve software wise. So that's the basic. That's really what all you need to know from this. I think this next slide in here. Let me go back to the PowerPoints. I'll just keep it like this. Where were you up to? Oh, that's the last slide. Not distributions. We were way back. Unfortunately, we're way back. I think it was this slide. Nope, wasn't that one. It's this one, the freeware one. So this is the different kinds of licensing for Linux. There's open source. Closed source is just software that you're not able to like get in and change, right? So like Microsoft Word, you don't have to charge for it. It can be closed like that, where you can't manipulate it, but still be free, as in free beer. And if you go to the GNU page I just showed you, they talk about the distinction. All the stuff under the GPL is free speech. It's the way to think of it. Liberty. It's another way maybe to think of it. But Linux also has a lot of elements of free beer, which means you don't have to pay for it. It's kind of just put on the internet maybe if you want to download it. But not everything in the Linux world is free beer. Just off the top of my head, Red Hat. If you get Red Hat, I think you can install Red Hat for free, but you don't get the support for the enterprise. So it's going to be a business, right, that uses, they have a Red Hat server for something, and they want to make sure it runs smoothly. They want support from Red Hat. They pay for that support. So that's kind of how Red Hat makes its money. I'm not a business guy, so I might be a little bit wrong on that, but that's my understanding of it. It's the enterprise edition. So there's, and then there's shareware. Usually shareware is, you get some, these days especially, you would get something, and then to unlock all the features of it, you might pay for it after a little while. In the past, it was more like a time thing. You still see that sometimes, where you can use it for 3 months and then you have to pay. But that tended to be clunky, and I think most people switched over to the features, open up the features of the money version of shareware. Anyway, so we talked about this already. I'll try to speed through some of this. That's not quite as important, and I'll let you guys review those licenses there. Why do people use Linux? One reason was it's responsive to like changes in the environment, because you've got this collaborative thing where you can just like update quickly. So you see that here. Yeah, and you're not dependent. You've got a whole community, open community for Linux. If you like say somehow, who knows how it would ever happen, but say Apple goes out of business, there goes all your support for Apple. Apple's very proprietary. It does actually, it's based on a version of Unix apparently now. I would have said Linux, but apparently they say it's Unix. But anyway, even despite that, like the way Apple works is very proprietary, and they like it that way. So if they ever go out of business, you're out of luck. So, and these like some of the things that's using, servers a lot. You hear a lot of servers as a use. I know in academia that's all we ever like use for like if you're doing like a machine learning type stuff. It's typically going to be like some Python thing you've written that runs on Linux. You guys in cyber, it's used a lot for pen testing and stuff. So it's basically anything a computer can do. I mean, but what are the advantages? I know especially back in the day, this is not too big of a difference now, but I know back in the day, servers that were Linux tended to be more stable. Like Windows is like you have to reboot it every day for it to be stable, and Linux could run for like ever. That's just one like anecdote. So I'll let you read that too. Yeah, flexibility and easy customization, right? You're able to get your hands dirty. This is why I prefer Android. I know you got some Apple fanboys. It's a fine product. It's great that they create the hardware and the software so it runs a little more smoothly, and it's cuter and more smooth. I mean, it's pretty, well, what's the neater, I guess, in some ways. But I like Android because I can get my hands dirty if I want to. And there's things I can do directly that are harder in Apple. I can afford an Apple, guys. It's not a prestige thing. But I'll never buy one. I might buy an iPad. I like those. But so that's the end of my my statement of which side I'm on there. And Android, of course, is based. It's running. It's a embedded Linux in your phone at the very bottom. So sort of like relates to this class that way. All right. Yeah, you can get support all over there. And the thing is whom are you getting support from is my only question. Like if it's Microsoft Word and you have a problem with Word, then ostensibly they're the experts on how Word works, right? And they can get into the nitty gritty behind the scenes and see what's going wrong. Now, in my experience, that's not always great. Like it seems like they don't know what's going on either sometimes, but you get the idea there. Less expensive. So it's. I want to just go down to this slide because this is the answer to one of your quiz questions. What's the cost of like a server, a Linux server? It's $0. I'm going to say that's not necessarily true. Like again, if you get a Red Hat package and you want the support, you're paying for the support. So technically, you're not paying for the OS in that case, but I mean, what's the difference if you're still paying money for that distribution or that release or whatever you want to call it? But that is the answer. It's $0. Notice everything else, you know, Windows 10 is greater than $0, or Mac is greater than $0. Here's a timeline of the history of Linux. We're not going to like necessarily go over this in detail, but you can sort of see, like, you know, it's the 90s is when it got started. And then it just reaches back into the past, into the Unix, you know, foundation, you know, it evolved from Unix and just computing, you know, operating systems in general. And that goes back to the 60s and the 70s. Yeah, and it says Multics here. That's Unix. So yeah, C was rewritten in the C. I mean, Unix was rewritten in C language. C was kind of developed. It was originally B, I think, at AT&T Labs, and then they made a version that would help them to write Unix better and called it C. So that's Unix, and these are some of the there's Berkeley. What is it? Berkeley Software Distribution. There it is, right there. That's a version of Unix. There was also Sun Solaris back in the day. That's what I learned on. And I had a picture of that pulled up and I lost it in the middle of this presentation. So I'm not going to find it again. But Sun Microsystems, the people who created Java that Oracle bought Java from, they had both the hardware and they had a Unix software called Solaris operating system that I learned Unix stuff on. There's this distinction. People will argue about this all day. It's a language thing. You could still say there's times when people say hacker when they mean this, and not just because they're uneducated or whatever. It's not a strict. I'm going to say the line between these two is blurrier than they depict here. But yeah, in general, like the hackers that are like proud of being hackers are like, we're just trying to find the limits of the capabilities of this tool or this machine or this software or whatever, right? And like, so, oh, look what I did. I tweaked this and now it does this nifty thing. That's like what the hacker mentality is. And like some people use hackers who do illegal, mean things. They use the term cracker for that. I don't think there's really any, there might be quiz questions on this. So if there are, that's what they mean. Hackers like the gray hat. I'm going to say gray hat at best. I'm not anti-hacker at all. I'm just saying it's kind of disingenuous to say that hacker is always like some holy angel or something who's just a genius who understands how things work. But anyway, next slide. And you got GNU. We already talked about that, and you know there's a whole hacker like mentality to that GNU stuff. So I will say, if you use GCC to compile a G program or G++, that's the GNU. That's a GNU version of the C compiler. For you guys who've done some of that, we'll probably encountered GCC in this class, I assume. But so Linux, get back to this. Linux, it's named after Linus Torvalds. He's Finnish, so it's not Linus. The pronunciation, it drives me up the wall. Some people insist on Linux, and it's just wrong. I'm sorry, it's just wrong. It's like GIF. GIF is correct. It's not GIF. GIF is just wrong. I know a lot of people say GIF. They think it sounds better. It stands for graphics, what does it stand for? Graphics interchange format, yeah. It stands for that, so it's a hard G. Well, JPEG stands for Joint Photographers Experts Group, and you don't say JFEG. So I'm sorry. The guy who created it specified at the time that he created it that it's pronounced GIF. So you're wrong. And same with Linux. The guy who, and I shared this in the class. Let me pull it up. Here it is. This is I actually Googled this, that somebody made a little video, but I Googled it because back in the early 90s, well, late 90s, not early 90s, in the late 90s when I was setting up Red Hat, you knew that your sound card was working if you heard this.
Hello, this is Linus Torvalds, and I pronounce Linux as Linux.
So, oh, sorry, I didn't mean to do it twice. So his name's Linus Torvalds, and he pronounced Linux like Linux, as Linux or whatever. So, just to settle that question, it's Linux. It's Linux in this class anyway, not that it comes up a whole lot because we don't actually talk a lot in this class. But anyway, let's get back to the PowerPoint. Here we are. Cost reduction. All right, so yeah, he was working on something called Minix, which was like a sort of an emulation of Unix that was used for teaching programming and stuff. I think it was like a French machine, if I remember right. And he was messing around on that, and the Usenet news group for that. You guys look up and see what Usenet is before you had the World Wide Web. I was actually on it before the World Wide Web, so I was in alt.folklore.urban a lot myself. I wasn't in this geeky one. It's all geeky, but I wasn't in this very hyper geeky one, the Minix thing. But he posted, and I should have that. I keep losing track of what I've got here. Here it is. Here's it says first email. I think it was actually a Usenet news group message, but here's where he's talking about creating his own operating system as a hobby. You notice he says it's not like GNU or whatever. But anyway, the key thing about this particular operating system that he created as a hobby, a fun thing, and this is where it grew from right here. He's not taking it seriously, but it turned into a phenomenon across the world, right? The key element that made that happen was, he says, it's 386, 486. That's the PC chip that was in all the PCs back then that your Windows ran on. So I guess it's Intel, I guess, but it was the 386, 486. This works on 486 machines or whatever. Back at the time, you would kind of have to know. The fact that he wrote this operating system to run on top of a PC chip meant that a lot of people had these PCs, maybe an old one they don't use anymore for Windows, maybe they don't like Windows, and regardless, they would install Linux, basically a Unix type operating system on the PC they already had. So you can look it up. That's my interpretation of it, but because I was there at the time, and that's what I took from it. Hey, I can run this on my computer I already have. So, and you could even run it alongside, dual boot or whatever, boot into one, boot into the other. The point was it would run on that hardware you have. You didn't have to buy a Sun Microsystem Spark box or whatever BSD runs on. I don't even know the hardware. So you could run it on the thing that you've already got in your house, which was affordable. So it's a free operating system that would run on an affordable hardware. And to me, that was the key element in its explosion. So nothing else you get from listening to this little lecture on these slides, that's probably the key thing, is this guy in Finland created an operating system that ran on computers that people already had in their homes. All right, and then people bought into it, right? All the hacker stuff was like the hacker, hey, let's see what this can do, and they collaborated and added to it, and now you've got what you've got today. They just added a bunch of now the different kinds, versions of basically you'll have the kernel, right? That's one thing that everybody uses. And then the libraries that go along with that kernel and stuff. But then you can have different distributions. What's different about the distributions are the applications that come with it. You can write all kinds of different applications on top of that operating system, right? So, for example, some distributions might prefer GNOME, some might prefer KDE, and they'll have different things that they package with them. That's what makes them different from each other. One thing about Gentoo that you see mentioned here is that you could download the source code and specify what your operating system was, the hardware you have, and change some flags in that compilation, and it would compile your operating system and any software you got with it precisely for that hardware. That was one of the cool things about Gentoo. It would take all day sometimes though, or more than one day. A lot of these different operating systems that you use, like Ubuntu and Mint and stuff, are based on Debian, by the way. In my mind, there's like these 3 bullet points are actually kind of like, I wouldn't say that Mint's with Gentoo. I don't know why they're on the same bullet point, but Mint's from Debian, Ubuntu's from Debian, Red Hat. So these are there's lots of different distributions of Linux, but these are like 3 of the main ones right here represented: Red Hat, Debian, and Gentoo. I guess there's SUSE too. There's some other ones. Okay, I'm back after another slight pause. While I was pausing, I was remembering I didn't really finish everything I wanted to say about GIF, but I'll save that for for later. What was the other thing? Giraffe, gigantic. I mean, you can't make that argument either. But anyway, one other thing. Anyway, so getting back to this, Linux. Yeah, you could say Linus in English is what we would say. So Linux, that's an okay argument. But I'm just going to say through usage, just like GIF. Back when I first learned about GIFs, they were brand new and everybody said GIF. I'm letting you guys know, nobody said GIF. Anyway. So next slide. I'm very opinionated about that subject. It just like makes me mad that people are so insistent on being wrong and saying that they're right. Anyway, so I'm going to rush through some because this is what frankly it's kind of boring. It's a lot of about how it's used and stuff. It's used for all kinds of things, obviously, and the big thing is it's free software that's got that collaborative thing going. It doesn't have a chokehold from a company, so there's all kinds of things that can be put to use as long as you trust that it's going to be stable and secure and do what you need. And there's a lot of people working on to ensure that's true. I did want to talk about this. This is kind of like kernel before, the core component for the GUI in both Unix and therefore later in Unix. Linux is that it's called Xwindow. Now it says Xwindows all throughout this stuff, and it's another thing where people are wrong. It's really not important, and I can see why people do it a lot. But I just want you to know for the record that the name of it is the Xwindow system. That's the trademark. There it is in Wikipedia, but we'll go to the actual people who I think these are the people who make it. So it's Xwindow. And if you want to be pedantic like I am, and you're working somewhere or intern or something, actually, comic book nerd or whatever, it's Xwindow, not Windows. But this is the core component of how you do most GUI. I can assume there might be a different library for doing this, but this is the one everybody uses that I know of. This is what allows you to make a window. The library that allows you to create a window. Now on top of that, you can have, back in the day especially, I'm talking late 90s, you would have what's called a window manager. That's a software that uses Xwindow to create windows. And the thing about the different window managers is they had different feels and looks to them. It was an aesthetic thing. So there was one called Favorite Window Manager, I think, FWM. And the thing is, back in the day, if you were a student and you had to work on a Solaris box or whatever, there were things you could configure, and one of them is your window manager, and there would be fads, oh, what's that one you're using? It allows you to change the color of your text or whatever. It's FWVM or whatever. I can't remember. FVWM. I think that's the one I used a lot. There were a lot of them, and so the basic functionality is Xwindow, but to dress it up, you would have different window managers. And then a window manager might be packaged in your desktop suite. So GNOME might have its own one or several different options of window managers that KDE has a different selection maybe. And that's when I say desktop environment. It's the K desktop environment, and GNOME, I can't remember. I used to know what it stands for. It's the GNU something. There's somehow a desktop environment in there too. It would be a whole suite of things that you take together to run on top of your Linux to give you a different experience from a different variety. And you'd have both on the same distribution, right? I want to say Debian had both KDE and GNOME. You could choose between them if you wanted them. All right, so going forward from here, Yeah, very distributions are essentially the same under certain. That's true. I mean, they all have like a particular Linux kernel, and that part doesn't change. It's just the dressing up on top of it that's different, and the applications that you choose to ship with that distribution, and the package manager, for instance, how you install new programs might vary from one to the other, and then like be used on. You can use ones on one package manager from one distribution on another distribution. So it gets kind of messy, but like again, at the very bottom, they're all the same. They're all Linux. They all have a particular Linux kernel that they're running. Oh, it talks about GNU. GNU Object Model Environment. Thank you. Is what GNOME stands for, and then you got the K Desktop Environment. So yeah, GUI environment has a window manager, which I was just telling you, and then a desktop environment. You'll get more familiar when you actually use them. You'll see how they're different from each other. And just showing you what GNOME looks like. Like to me, it looks spiffier. I don't know if it uses more resources to do this, but I like the way GNOME looks. But I have used KDE before because maybe it would have something that the other one didn't or whatever. So yeah, package manager installs and maintains software. So RPM, the Red Hat package manager, is like, it says the most widely. I would almost say that APT, the one for Debian, I used to know what that stands for too, but it's package something, apt-get. That's the one I'm more familiar with actually, because I use a lot. I favor Debian in my distributions. So by the way, that stands for husband and wife. Deborah and Ian is where it comes from. So it is Debian, not Debian or whatever. It's Deb and Ian. But anyway, yeah. And Tarball, this is one of your questions too on the test. So Tarball is a compressed archive of files. Really, it's a tar, which is a way of turning a directory structure into one file, and then you would like zip it up and compress it. So tarballs used to be the standard way of like installing like new software on your computer or whatever, but package managers make it a lot easier. All right, so in the common uses of Linux, obviously these are things that you'll learn throughout the whole course because you will see how they're used in all these different areas. Mobile devices is Android. Android's got by far the hugest share of the mobile market. So every Android phone has Linux running underneath, a version of a specific implementation of Linux that the Android operating system runs on top of. All right, and yeah, and that's just a slide you can read. FTP, all kinds of different things Linux servers might be doing. The cloud, just remember this is another term for the internet. Stuff that like runs across the internet or is hosted, a server hosted on the internet that you can maybe even like run programs on or something. But and this is the other question. The most common Linux method of clustering is Beowulf clustering. So there's an answer to one of your quiz questions. And I think this is pretty much it for what I wanted to cover. Yeah, here's a summary. But if you have any questions about the lecture, post them in the help forum, and I'll be happy to answer them. And this lecture is already too long, so I'm going to watch it again and make sure I didn't catch anything that wasn't supposed to be in there, and I will talk to you further. There should be some further videos coming. I'm not sure exactly how I'm going to deliver them yet, but we'll see.